Right guys, I'm just going to show you the reactivity for group 1 metals. So group 1 metals, I've got a list of those here. They are also known as alkali metals. The reason why they are called alkali metals is because when these metals react with water, they form metal hydroxide, which is an alkali. Okay, they also produce hydrogen in that reaction, but because it produces that metal hydroxide that is an alkaline, that's why these are also known as alkali metals. Okay, so if we just have a look at this, I've made some notes on the board already, but I'll just guide you through it. And so if we look at the reactivity of group 1 metals, the first thing that we do need to know is that in order for something to react, it needs to form an ion. Okay, so that's how it will react first. So in order to form an ion, because they're all from group 1, they will need to form a 1+ charge. Okay, so lithium, for example, will have 1 electron in the outer shell. We'll need to lose that electron to form Li+. All of these will actually have 1 electron in their outer shell because they're all from group 1. So the group number will tell you the number of electrons in the outer shell. Okay, so all of these will have to lose 1 electron to form the ion. Okay, so for example, Li+, Na+, etc., K+, they're all the ions. Okay, so now if we just have a look at this, so we need to form the ions for the reaction to actually occur. In order to form the ion, like I said, we need to lose an electron. Okay, so when we're talking about reactivity, we need to look at how easy it will be for group 1 metals like lithium or sodium to lose an electron. Okay, that will depend on a lot of different factors. The first thing that we do need to know is as we go down the periodic table, down the group, the atomic radii will increase generally. Okay, and there's a couple of reasons why the atomic radii will increase, and that will affect the ionic radii and also the reactivity. Okay, so what you can say is as we go down the group, the atomic radii increases, therefore the ionic radii will also increase. Right, lithium will have 3 electrons in total, so we'll have 2 shells. Okay, sodium will have 11 electrons, so it'll be 1, 2, 3. Okay, potassium, the shielding increases. Okay, so as we keep going down, the shielding increases. Okay, I'm not going to draw the shells accurately here, but I'm just visually showing you what's happening. So as we go down to cesium, all the way down to francium, I'm not going to draw francium here, but you get the idea of it, the shielding increases. Okay, the reason why shielding increases is because the number of electrons will increase. So if you look at your periodic tables, lithium will have 3 electrons, sodium will have 11, potassium will have 19, rubidium will have 37, cesium will have 55, etc. Okay, so as we go down group 1, the number of electrons increase, which means the number of shells will increase. Okay, so we use this keyword called shielding. Okay, examiners love the word shielding. Okay, you always see that word in mark schemes. So as we go down, the shielding increases. Okay, I'm just going to write this here. Okay, so the shielding increases. Right, so we know that the shielding increases. So another keyword that you do need to know about is nuclear charge. Okay, I'm just going to write it here. So the nuclear charge decreases. Okay, so it goes down. So as we go down the group, the nuclear charge decreases. So this is what happens in your periodic table. When you go down a group, the shielding increases and the nuclear charge decreases. So the term nuclear charge means the ability of an atom to pull in the outer shell electrons, or the ability of the positively charged nucleus actually. Okay, so we have a positively charged nucleus in the middle because the nucleus is made up of neutrons and protons. The protons are positively charged, so the protons in the nucleus is what's causing the electrons to be pulled in. Okay, so that's why we have a positively charged nucleus in the center. Yeah, and those will be pulling in any outer shell electrons. So as we go down, what happens is, because the outer shell electrons, so all of these have one outer shell electron, is getting further and further away, there will be very little attraction for those outer shell electrons, okay? Because the distance, if I show you this, if you look at lithium, the distance between the positively charged nucleus and the outer shell electron will be quite small. But as you go down, that distance is increasing, okay? If that distance increases, there is less pull for the electrons in the outer shell, okay? So that's because nuclear charge is also decreasing, okay? We can also say that the electrostatic charge gets weaker. The electrostatic attraction becomes weaker, okay? The electrostatic attraction is the attraction holding together the positively charged nucleus and the electron. It's essentially actually all holding together the whole atom, okay? So this attraction is really important, electrostatic attraction. So electrostatic attraction is an attraction that exists between something that's positively charged and something that's negatively charged. In this case, because we're talking about an atom, it will be between the outer shell electron and the positively charged nucleus, okay? So as we go down group 1, that distance between the outer shell electron and the positively charged nucleus is getting bigger and bigger, okay? And that electrostatic attraction weakens. So we've already spoke about 3 things so far. So shielding increases because the number of electrons are rapidly increasing as we go down, okay? Nuclear charge decreases, so there's less of a pull for the outer shell electrons, okay? And the electrostatic attractions also weaken. That's also to do with the shielding, because there's more shields, because there are more shells, that causes more shielding. So in a way, these shells act as a bit of a barrier for the attraction. So these shells act as a barrier which weakens the electrostatic attraction between the positively charged nucleus and the outer shell electron. Right, as we go down, all of this is happening, okay? What that means is that it becomes easier to lose the outer shell electron, okay? So like I said before, because we're talking about reactivity, in order for it to react, it needs to form an ion. To form an ion, it needs to lose an electron, okay? So as we go down, it becomes easier to lose that outer shell electron, okay? These outer shell electrons. So if it becomes easier to lose that outer shell electron, as we go down group 1, the reactivity increases, okay? The opposite is true for halogens, which we'll have a look at later.